Hello, this is Mr. Collier, and today we're doing geometric sequences. We've done arithmetic. Geometric is the other type that you need to know for the IB. Okay, so let's say we have a sequence starting with 3, and that's the first term, and we have a common ratio, um, which we call R. So geometric sequence, each term can be found by multiplying the previous term by a common ratio, which we call R. Okay, so in this sequence, if we start with 3, then we keep multiplying by 2, and we get 6, 12, 24, 48, 96. So it's multiplying by 2 each time. Okay, it's called a ratio. That means division, because if you take any two terms and divide them, any two consecutive terms and divide them, you always get the common ratio of 2. So you can calculate the common ratio by dividing a term by the previous term. This is nth term down here, sorry. The nth term is going to be the first term. Notice you're multiplying by a bunch of 2's. Alright, so let's look at the 10th term. The 10th term would be 3 times 2, and to get from the first term to the 9th term, we multiply by 2 9 times. So that's why it's 3 times 2 to the power 9. So the general nth term is 2 to the power of n minus 1. We have to subtract that 1. Okay, so that's the general rule for the nth term in a geometric sequence. It's the first term times the common ratio to the power of n minus 1. Okay, so which of these are geometric? So they're only geometric if you divide them and you get the same number. So 6 divided by 3 equals 12 divided by 6 equals 24 divided by 12, which is 2. So they all give you 2, so yes, it's geometric. Here it looks like we're adding 2 each time. So we have 4 divided by 2 does not equal 6 divided by 4, so it's not geometric. In fact, it's arithmetic. This does not look geometric. It looks like the square numbers, but you can show it by showing that 4 divided by 1 does not equal 9 divided by 4. So it's not. This one, let's divide. 2 divided by 4 does equal 1 divided by 2. Right? That's half. And 0.5 divided by 1 is also half. So yes, it is geometric. So how do we determine? We just divide each term by the previous term. And if those are equal, then it is geometric. Okay, so you can complete these. You can see where these numbers are multiplying by 2 each time, so you can just keep doubling them. Sometimes R is a negative number, so it fluctuates between positives and negatives. So next one's going to be negative, and 3 times 27 is 81. Next number is going to be positive, negative, positive. Here, what's the R value? To determine the R value, I'll just take these integer ones. It's easy. R is negative 3 divided by negative 6, so that gives you half. Okay, so to get the next term, you multiply by half, you get negative 3/8. Then negative 3 over 16. And if you go backwards, you're actually multiplying by 2, so you can go backwards as well. Here the R value is 5 divided by 1, which is the same as 25 divided by 5. It's 5. If you want to go backwards, we got to divide by 5, so you can write them as fractions. That's the easiest thing to do. Okay, so this is what the formula for the nth term in geometric sequence looks like in the formula booklet. We just derived it above. And next time we're going to look at the sum of a geometric sequence. Alright, let's take a look down here. So for each of these, write down the first term and u1. Well, that's pretty simple. u1 equals 2. R equals 6 divided by 2, which equals 3. Here, R equals 6 divided by negative 3, which is negative 2. And you could do 24 divided by 12 as well. You get negative 2 each time. And here, R is, well, you can do 2 divided by 4 is half. And u1 is 16. So then you can get u10 for each of them. u10 is the first term times r to the power of n minus 1. So whatever that is. And negative 3 times negative 2 to the power of 9. And this one, u10, is 16 times half to the power of 9. Okay, so let's just do one of those. I'll do this one here. Make sure you have it in the brackets or you will get the wrong answer. Or possibly get the wrong answer depending on the context. But generally you need your brackets around these negative numbers. Alright, these numbers get pretty big pretty quickly. So even if we go up a couple more terms, you'd probably be in the millions. 1,536. Okay, let's look at a couple examples. Caroline's starting a new job at $48,000 a year, and her salary increases by 5% per year. Show that this follows a geometric sequence. Well, here's U1. Okay, next we would increase that by 5%, so we can get 5% and add it on. Well, we can just do 1.05 times 48,000. Okay, and then we get 50,400. And the next one, you would just multiply by 1.05 again. 52,920. Okay, and obviously what I just did there was I multiplied by 1.05. Each year you're multiplying by 1.05. So that's the R value, because that's what we're multiplying by each time. And of course U1 is $48,000. So the 50 year of work is just U5, and we take the first, the initial amount, and do 1.05 to the power of n minus 1. And we get whatever that is, 48,000, oops, 48,000 times 1.05 to the power of 4. 58,000, 344, 30. Okay, next, the third term of a geometric sequence is 63, and the fifth term is this. We can use the formulas in the formula booklet, but I just do it logically. Third term is 63, and then you got the fourth term, and then the fifth term is 567. So how do you get from the third term to the fifth term? You're just multiplying by r twice. So 63 times r squared equals 567. Okay, and you just solve this. And well, let's just write it in all in one step on the calculator. So we go to square root, make a fraction, oops. Square root, fraction, 567 over 63, 3. So r equals 3. Okay, next we have, for the geometric sequence, determine the value of x. Alright, so remember I said before, geometric sequence is all about r, the common ratio, right? If it's a geometric sequence, then that means when you divide, you always get the r value, and you always get the same thing. So this means that x divided by 6 has to be equal to 13.5 divided by x, and we can solve this, right? So we get x squared equals 6 times 13.5. Alright, and then we get, let's do that, 6 times 13.5. We get 81. And then we get 9. Now technically when we're doing this, you should do positive negative square root. Because there's two possibilities. R could be negative, like this could be a negative number in the middle and then be positive, negative. It could be one of those alternating sequences. All right, but usually the IB questions are in context and you just take the positive one. So you could say it's positive -9. Which term in the sequence? Which term in the sequence is this? Okay. Well, here we have u1 equals -2 and r equals 6 divided by -2 is -3. So the formula is -2 times -3 to the power of n minus 1. And we just sub that in and solve for n. Okay, so we can, well actually, because n is an exponent, we're definitely going to have to solve by graphing. So let's do that. And we have this. Alright. And now n is a whole number, so you should be able to just look it up in the table instead of by the graph. All right, the numbers are getting bigger and bigger. Oh no, they are not. Let's go back. Oh, it's the eighth term. The eighth term is 4,374. Okay, so n equals 8. Is 486 a term? Well, we can solve 486 equals -2 times -3 to the power of n minus 1 by graphing, or simply look it up in our table. Yes, it is. It's the sixth term. So yes, u6 equals 486. And sometimes you want to show your table as part of the work. It says 46. Okay. Now let's see. Now this one here, we did one like this before. This is just u4 to u7, so that's 24 times r cubed equals 192, and you can solve for r. This one, we just did an example like it. Yes, so you can probably do all these yourselves.